With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello students, so the question is, in the figure shown, a planet moves in an elliptical orbit around the sun. Now compare the speeds, linear and angular momenta at the point A and B. So let's see the solution here. So simply in this question we can see that we have given two satellites. Okay. No, actually according to question we have given a satellite which is revolving in an elliptical orbit, which we can see here into the diagram. Okay. Now as per the question we have to compare the speeds at these 2 points A and B, while we have to compare the linear and angular momentum at these two positions of the satellite, that is A and B. Okay. So before of that, let us know about something Kepler's law. Okay. So what is Kepler's law? It states that is Kepler's law of areas is a consequence of conservation of angular momentum of the planet about the sun. So since we know the centripetal force, okay, what we know, that is the central force is given by f of g is equals to j capital M small m divided by r square into r cap, where r cap is a unit vector, passes through the sun, and the torque of this force about the sun is 0. Therefore, its angular momenta about the sun at this point A and this point B will be equal, or we can say remains constant. So simply here we can state one thing, that is LA, this will be equals to LB. This implies that MV1R1 will be equals to MV2R2. From here M get cancelled, while we get V1 by V2 is equals to R2 divided by R1. Let's suppose this as equation number 1. Now here we have to compare the speeds, linear and angular momenta at point A and B. So for that we can see here that is the distance of position A from this sun is R1, and distance of position B of satellites from sun is R2, while their velocities V1 and V2 are the respectively. Okay. So here we got the one relation between the speeds, that is V1 by V2 is equals to R2 by I1. Now let us look the linear momentum. Now here we have already written linear momentum LA is equals to LB. So if we take the ratio of it, let's say as L1 by L2, so it will be equals to how much? MV1 R1 divided by MV2 R2. So this will be equals to MM will get cancelled here, while V1 by V2 is how much? That is R2 divided by R1, and here already we have R1 by R2. So simply we can say that R2 get cancelled, R1 will be cancelled, and we get here the relation between the linear momentum at this 2 point, that is L1 will be equals to L2. So this is what we got, the second relation. Now for the third relation, we simply say the angular momentum's its ratio, it will be equals to MV1 divided by MV2. MM get cancelled, it will simply become equals to V1 by V2, or we can say in the form of distance, that is it will be equals to R2 by R1. Okay, and here we got the third relation. Okay, so this is what the required solution for this particular question. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.